Hello everybody, Chris here, and in this video I want to show you guys how to set up and use my Grid Builder plugin with a isometric 2D game inside of Godot 4+. So in this tutorial project, I've gone ahead and created a 2D node. I'm calling it World, and under that is nested a tile map. And you'll see in the file system I've included Kinney's isometric tower defense files, so that's a freely available pack if you want to go ahead and follow along using the same files. So before we get into the plugin itself, I want to show roughly how I'm setting up the isometric tile map. Tile sizes can vary a lot with isometric games, so I want to show the exact settings I'm using so that you have that information. So for tile map, I'm going to go over to tile set, click down here, new tile set, and then I'll expand the resource here so we can see all of the details. So you see the tile shape is set to the default square for top-down or platformer games, but we want to click on the drop-down and change this to isometric. So the tile size will default to 16 by 16, but if we take a look at our actual files, so if we double-click on one of the images, we can see that the image size is set to 124 by 123 pixels. Now that might be a little confusing because that's not going to be the actual grid size of the tile map itself, but we can use that as a starting point to kind of figure out how we need to adjust the grid size. So I'm going to click on tile map and let's go to tile size and do 124 by 123, hit enter. We should see the grid kind of scale up a bunch. And then let's try bringing in one of these images to the tile set window. So that's at the bottom when you have tile map selected. I'll go down to 106 since I know that's the grass tile. You might also notice that for a lot of these isometric packs, they might give you 4 of the same image. That's one for each rotation direction. So in your actual game, if you're going to have a rotating camera, you're going to have to figure out how you want to swap out the images as you rotate the camera, which is a whole nother thing than this tutorial, but just keep that in mind. So I'm going to start by bringing in the 1060 image, and let's pop that in there. And we can say we'll automatically create a tile. So that's just going to kind of bring that in over here. And then if you look at this red outline that kind of goes around the tile, you can see the grid, how the grid would layer on top of this tile. And you can see that that is pretty much completely wrong right now. So the Y is way too stretched. We want the grid to actually go around the surface area, not the entire image size. So that's basically part of why your tile size is going to be very different than your image sizes. So we can just take the tile size on the right and scale the Y down. And as we do that, then you'll see, especially in this window here, the red outline of the grid size is going to be squeezed vertically inwards. So we just kind of need to adjust this until we get the right size. So I've already kind of tested that 70 pixels is kind of what we're looking for here. And I think it might have been 120 for the tile size itself. So if you kind of left click around, it should kind of update up there. And what we can do to test is go to the tile map window, which looks a lot like tile set, except here you can select a tile and you can draw onto the tile map. So I'm going to left click there and press to put it down. And we can see with the tile size of 120 by 70 pixels that this looks to be correct, at least in terms of sizing. Now the offset here is wrong. And also with this stacked tile layout, we can see that it is not rendering correctly. So what we want to do is change the tile layout to diamond down for this particular case. And you can see that when we do that, it kind of messes up the placement of our tiles entirely. So you want to figure that out and then probably never change it. But now that we have diamond down set, we can kind of see that our grass tiles are now rendering on top of each other correctly. Now one more thing concerning rendering. Over here on the left for the tile map, you'll see that when you have a isometric tile set, that they want you to enable Y sort so that your tile map sorts with other objects on the screen correctly. So to fix that, we want to have tile map selected and go down to ordering and then check Y sort enabled. The error message will still be there because we also need to Y sort the layers. So under layers, we have the default layer, layer 0. I could just rename this to be ground, make it make some more sense, and then check Y sort enabled. So as long as your layers here are Y sort enabled and your tile map is Y sort enabled, then the warning message should go away. Okay, so we're kind of like halfway there now. So let's go back to tile set and adjust our tile here. So now we basically need to take this grid box and move it upwards. So this is a offset problem. So let's use select, we'll grab this tile, and then we want to go to rendering and texture origin. We want to decrease this so that the grid box moves upwards. So let's just hit negative on this until the grid box aligns. That looks like negative 16 pixels. So now if we look at our tile map grid, we can see that the actual surface of our ground tiles aligns with the tile map grid. So that's basically what we want to see. So now that we have a simple tile map kind of set up for our game, we can go ahead and bring in the plugin. So in the resources of the file system, I'm going to right click here and create a new add-ons folder if you don't have one already. It should be called add-ons lowercase. This is the standard place for installing Godot add-ons. And then inside of here, I can right click, open in File Manager, and then I'll locate where I've downloaded Grid Building 3.2 or greater. So 3.2 is when Isometric started to be supported. So let's open this up, bring in the Grid Building folder, and just drop that in. So now back in Godot, we should see the folder right there. We can go to Project, Project Settings, over to Plugins, and enable it right here. So how I'm structuring my games currently is that when I have systems like Grid Builder, I would have those pulled out separately from the world and the levels itself so that the levels can be loaded and switched out interchangeably while the systems remain there in the background and you don't need to reload the systems every time a level loads. So on a separate scene, I'm calling this gameplay. This would be basically what I would load after the menu screen. You hit new game, then gameplay loads. So this is kind of the main scene for the game project. So in gameplay, and this is just a node here, I want to right click and add a child node. I'm going to call this systems, just to kind of turn all of the game systems into a drop-down menu that can be expanded or closed. And then let's right click and add a child node. And then we want to search for build for building system. So I'm going to create a new building system, and we're also going to need a grid targeting system. So if I add a child node and we do grid for grid targeting system, then we have the two main systems for the plugin. So you'll notice in the inspector for both of them that they have external dependencies. How you set these up is kind of up to you, but the simplest way to do it would simply be to have them nested somewhere under gameplay and then to assign the path to the node here on the right in the inspector. You might notice that some of these nodes, like the tilemap, are going to be level dependent. So both of these have a method called change level setup. So you can call that if you just want a convenient way of updating the dependencies whenever you switch a game level out. But for the simplest setup possible, I'm going to just bring the world into gameplay nested beneath it. So basically everything in the world scene we can now see on the screen here. And if we right click on world and do editable children, then that's going to expose all of the child nodes. So we can go into building system and assign the tile map like this. And then grid targeting system, we can assign the tile map as well. Next, we're going to need a 2D node for handling the positioning of the building and grid targeting system on the screen. So this is eventually going to snap to the grid positions as we move our mouse around the screen. Now, right now in the world scene, if I jump back into that, we only have a tile map here, and there's really no indication of separate levels. So what I might want to do is actually create a level node. So if I search for node 2D, I'll just rename this level and bring the tile map under it. This way, you could switch out the level rather than switching out the entire world. And now back on the gameplay scene, if we want to add in a positioning node for our mouse cursor, we can add it to the world rather than the level. And that means when we switch out the level, that the positioner still exists within the world and we don't need to reset it or anything. Okay, so in the plugin, if we just search grid, there should already be a default scene for a grid positioner. So I'm just going to drag this under world. And then if we zoom in on the screen, we can see that we have this little grid indicator. Now these sprites were set up for a 16 by 16 square tile set, but we can manipulate it for a placeholder until you have your own custom indicator. So I'll right click here and do editable children. And if we just click on the grid targeter, then we can play around with the transform here a bit. So I might just take the scale and make it something like 4. And then if we take the rotation and make that 30 and the skew 30 as well, then we can see that that actually layers much better onto our grid. Now, you'll notice it's really blurry. That's because of the filtering settings on our project. So we can go to project settings. And if you scroll down to rendering textures, you can change this to nearest if that bothers you, and hit close. And then we can see that we have more of a pixel perfect display for that graphic. Now, I did use Skew here to manipulate the texture, so it seems like a convenient way of taking a rectangle and making it fit onto an isometric grid, but I would recommend against doing that for collision shapes specifically. For collision shapes, you can use a collision polygon 2D in order to draw in the shape of the grid when you need to place down a collision shape on an isometric. So for the rule check indicators we'll be setting up, we're going to use collision polygon, not a skewed collision rectangle, and that will make sure that the collisions work properly in the actual game. Okay, but we have this grid positioner, so I need to take the building system and assign that grid positioner, and then grid targeting system as well. We assign the positioner and make sure the tile map is set as well on both of them. Okay, so place objects parent. This is when you place an object into the game world, where do you want your placed objects to go? So you're building a castle or a tower. What part of the hierarchy do you want that to be nested under? So that makes sense to be actually within the level itself. So I'll jump back into world, and under level, I'll right click add child node, and let's do node 2D here. Since the only thing we'd theoretically build in a tower defense game would be towers, I'll just call this towers. Save that, and then back in gameplay, we assign the target to be the towers node. So this would be another one of the nodes that get updated whenever you change out the level. You just have to make sure you reassign it when you load a new level, the same way you would assign any other property in Godot. And then lastly, the placer. So this is the object that is considered to be placing the objects into the scene. So if you have an actual character, it might be that character who spends resources and places a building into the game world. With a tower defense game, that would be more of just a god overview figure. So honestly, it doesn't even need to be a 2D node. We could just go to gameplay here, right click, add a child node, and I might just call this node, rename it to be player. And then if you have any other scripts tied to the player, such as a player inventory containing how much gold resources you have to build buildings. So if you want to use the default spend resources rule in your tower defense game, then that would be the grid builder inventory side add-on that you can download on the same page you downloaded Grid Builder. But we're just focusing on getting the plugin to work with Isometric here, so we're going to gloss over that for the sake of time. On building system, we just need to assign the placer. So the placer is the player. The player places objects into the game world. Just think of it like that. All right, so now we should be able to load up our gameplay scene, and the grid targeting system should manipulate our grid positioner node and snap what you see here to whichever grid tile we're hovering over. So to make sure that we use gameplay when we launch, let's go to project settings, and run. We select a main scene. So for now, this is going to be gameplay.tscn. So if I hit play, you can see that the grid targeter is snapping based on the tile size around the tile grid. You can see if we go up here to the top left, where we actually have the tiles, that it is actually targeting the areas for the tiles properly. Now we do want to make sure that our tile map's actually visible. So let's add in a 2D camera as well. So depending on what makes sense, you might put that on world or level for you. I'll try putting it on world. So a camera 2D, and we can see that this is already centered with this purple box on the 0, point. So that'll probably work for right now if we just hit play. Okay, so now we can see the tile map a lot better. You might want to make the camera be able to move around the screen so that if your tiles go off the screen, you can see it better. So I can do that real quickly just with a right-click attach script. And I'll just call this move camera.gd. Let's put it in a different folder here. I'll just call this source for source files. And open, create. So this is going to be a really quick script. I'm going to do @export var move speed. Let's set that to 100.0. When we hit save, we can see move speed just pops over here on the right. And then on process, we want to get the direction from input.getVector. And this is going to be, let's just say left, right, up, down. Yeah, okay, that's right. So if we go up to project settings, input map, add new action, I'll do left, right, up, down. So to control the camera, left is going to be A, add a key, A on the keyboard, okay. So now A causes the left action to trigger. Let's do D for right, W for up, S for down. Okay. So now when we press WASD, we can get the vector input and we know the direction we're trying to move in. So our node 2D, our camera, we just want to call self.translate, and we're going to do direction times move speed times the delta. So the move speed is going to be how fast we move per second. The delta is the number of seconds or fractions of a second between frames. And then the direction is, well, obviously the direction we're trying to move in, whether that's up, down, left, right, or a combination of the two, like top, left. Okay. So now if we hit play, we should be able to move WASD, the camera. Maybe we want to bump the move speed way up. So I'll make that 500 pixels because I guess our grid size is quite large here. And there you go. You have a movable camera. So you probably actually want to also apply the camera script from inside of the packed scene for the world. When we're editing it here, this is only this one instance that's going to have the script. But if we go into world, we can rename our camera to move camera. And then I'm going to take the GD script and just put that here. Move speed set to 500 so that it's faster. When we save that, it should update back out here on the world. Right, and just click here to make sure that our move speed settings are correct. So now that we've done all of those prep steps, we can actually start setting up the placeable objects and work on placing objects on top of our tile map grid for your isometric game. So now that we have the tile map set up, let's go ahead and start creating a placeable object. So when we create a placeable resource, it's going to target a packed scene that we want to instantiate into the game on top of one of our tile map squares. And those objects are going to be placed in wherever we have the placed objects parent, which in this case is the tower's part of the level. So a packed scene would basically be any .tscn file that we want to instantiate into another scene. So really, we're just going over here to do a new scene tab, starting off with a 2D scene, and then figuring out what we want this 2D scene to be. So if we're making, let's say, a tower defense tower, let's just go here and rename it tower for right now. And then we're going to right click on the root node here and change its type into some kind of physics object. So if we search for body, we'll see the 4 types here that are available in 2D. We probably want static body 2D if we're building a structure, because generally speaking, those don't move. But if you did, for some reason, want it to have some custom movement, you could try animatable body instead. I think that would usually be more for like a moving platformer in, well, a platformer game, obviously. But then there's also character body 2Ds, which are your standard movable character if you're going to use WASD to move it around the screen, or left click to point in, like RTS style, send characters to a certain destination. And then rigid bodies, anything that can be affected by the physics of another object to be pushed or moved around the screen. So obviously we want a static body 2D here for a immobile tower. So let's choose that. And then because this is a physics body, it needs either collision shape or collision polygon. Since we're doing isometric and skewing a rectangle collision shape can cause problems within the physics engine in terms of proper collision detection, we should use a collision polygon instead. So I'm going to right click, add child node, and let's go up to collision polygon. We'll add that in there, and we'll worry about assigning the points for our polygon later. After we bring in the sprite. So let's right click on tower. I'll add a child node. Let's do a sprite 2D. And then we're going to need to get the art for a tower of some kind. So actually, if we open up the Windows Explorer for these components, we can see that for this specific pack, that these towers are built with kind of a modular element to them. So you would actually stack a few of these tiles on top of each other and then use that for the final tower. So for instance, this tower defense 24 tile might be the peak of a tower, but you still need a base tile. So we're actually going to need multiple sprites here, but probably only one collision shape still. So we can go ahead and grab a base tile. So I guess we'll try something like number 20. And I'll position that into the sprite 2D. And I can rename this base sprite 2D. And then let's right click and add a child node, and it'll be sprite 2D. I'll just say top sprite 2D. And then I'll locate another image that we can use. So I'll try 23 here. So I'm going to get 23, 0. It's important to make sure that for these 4 direction sprites that when we're using them, we use the same one. So later in your code, you might need to rotate all of your sprites in a scene when your camera rotates. So that's why you have 0, 1, 2, 3. But we'll take the top sprite and I'm going to position it above the background. So I'll hit W to go into move mode, and let's just move this kind of up in position to somewhere that might make sense. And this actually almost looks like there's supposed to be a third piece going between this base and the top. I guess that would be kind of like tile 9 here. So let's try adding a third tile. Sprite 2D, put that in there, and I'll just call this mid sprite 2D. And we'll grab image number 9, pop that in there, W to move, and kind of position it upwards here. So, yep, kind of like that. Okay, and we're going to want to save this tower, so I'll hit Control S, and let's create a folder for, let's say, objects. And then inside of here, I'll create a towers folder. And then I'll call this tower1.tscn. Very creative name, I know. So we'll save that in there. And to test kind of how this might look in the main world, I'll go to world. And then let's search for tower1.tscn and just kind of bring it in here. So eventually we're going to want this to kind of snap into position somewhere like there. Where it's going to snap is basically at this center point right here, the 0, 0 of our base scene. So we can see that if, like down here is our 0, 0 of the tile map, and this tile specifically, we actually need these sprites to offset a bit more, because right now it would actually snap more like this, right? So you can see these transform positions being right on top of each other. It's more like where things would be positioned, which is not what we're looking for. So we can leave that there for right now, and we'll create the placeable and test it, and then we'll adjust the tower scene to make sure it's actually placing correctly. So now we need the resource for the placeable so that we can actually tell our building system that we want to be able to place one of these towers. So let's right click on towers. I'll create a new resource. We're going to look for placeable, create that. And then you can name this however you want. You could call it something like placeable underscore tower1 or tower1 underscore placeable. I just think it's nice to be consistent with at least the base name of what you're dealing with, so that whenever you're searching in your file system, if you search tile1, it'll show both the placeable and the main packed scene. So I think I've been usually going with placeable underscore tower1, and then it's a .tres file, of course. So we save that, and then you can double click on the resource and start editing it. So now we can start defining the properties of our placeable. So our display name for tower1, we'll just say tower1. And this isn't necessarily the node name. This is how we want the placeable itself to be represented inside of the game. So we might use that for like a text display in a build log or something. So the icon, any symbol you want to display next to the name here, that could be like a tiny screenshot of the image, but it should be something quite small. Like you can see this gear icon, that's kind of more what you're looking for, or a little bigger than that. The packed scene, we're just going to assign tower1.tscn into this. So this is the actual scene we're going to place into the game. Honestly, we could just like screenshot this and use it as the icon. Why not? So I'm literally going to put the screenshot I just took into icons, and we'll save this as tower1 or icon tower1.png. Save that. Now I can just search the project for Tower 1, and we get all the Tower 1 assets. Let's just put that as the icon. Okay, there, bam, we have an icon. So next, an array of resources called tags. So if you want to mark a placeable as being belonging to something, like being a building, then you can take any resource saved to your project that would indicate that and put it here. And you can use the tags array to filter your placeables based on what they should be set up to do. So for instance, in the default placeable UI, it categorizes things based on the tags that are on your placeable. So if you want your tower to show up in the buildings category, then we would give it a building tag. And then placement rules, if you have a custom rule that you want specifically this tower or object to require to be true in order to place the object into the scene. For instance, this tower costs 500 gold and 200 ward, and you want to spend those resources on placement, but that might be a different amount than another tower, which requires like 1,000 gold and maybe no ward at all. So for those kind of rules that are placeable specific, you would just put them in here. And by the way, you can also create your own building rules. You just have to extend building rule and implement it. We might come back to this, but let's work on just getting the objects to place onto the grid first. And preview excluded nodes. If there is a node inside of the packed scene that has a script that you want to keep executing while the placeable is in building preview mode, then you can give the node path to that right here. So the reason why the scripts would be turned off is that you might have a scene that has some code like a rhino being able to move around the screen that you don't want to execute when you're still placing it into the scene. So by default, any scripts attached to the nodes in your packed scene are turned off by default, but you can put an exception here if you need to. And then you can ignore the base rules on the placement validator if you want to only use the placement rules of the placeable. Usually not going to need that, but that option is there. And then you can mark a placeable to be rotatable, flippable on horizontal, or flippable on vertical. Now, in this case, the only thing I'm going to check is flippable flippable horizontal, because generally for isometric, we're going to be rotating the camera. We're not going to be rotating the object itself. And as you can see from all the images in this pack, you have 4 images for 4 directions viewing the isometric tower. So instead of rotating the sprite, what you would do is you would replace the images. So for isometric, probably not going to have rotatable on, probably not going to have flip vertical, because that would be flipping the tower upside down, but left to right might make sense. It might not too. I mean, you can see the shadows are on the left, so maybe we'd even turn off flippable horizontal. But for now, I'll leave it on, and you can make that decision for yourself and your specific game needs later. Now let's go into gameplay. And let's add in the placeable UI so we can actually tell the building system what to build. So I'm going to right click on gameplay and let's add a canvas layer. So a canvas layer is basically going to group all of the UI in its own separate thing. And that way it'll layer on top of the screen, but any movement that goes on between our camera and the game world is completely separate from the UI itself. So generally, I'll have a canvas layer for the UI. And then we want to have the placement UI. So let's search for placement in the project. And placeable item list template. That's not quite what we wanted. Let's see, placeable selection UI. Okay, yeah, that's what it's called. So we could just take the default scene I included in the plugin and drop that in here. And we can see basically in this blue frame the bounds of our screen. And the placeable and then the placeable selection UI is positioned over here on the right by default. So we need to set up the external dependencies so we can use this to select the tower that we want to place into the scene. So let's put in external dependencies, the building system. I'm going to assign the building system right there. Okay, the placeable item list template is already set, but obviously you can customize that if you need to change how the item list works or looks. And then inside of settings, we can put in which placeables are actually active inside of the selection UI. And then categorical tags we will use to determine what items fall into which category. So for placeables, let's increase the array size to 1. And I'm going to click the drop down and quick load placeables from our project. So we only have one placeable tower 1.tres. Okay, so right now, if we were to hit play, it's actually not going to show. So for the sake of seeing this when it pops up, I'm going to do show at start so that this is active as soon as the scene starts. If we hit play, then we're going to see that the placeable is not actually active in this list currently. So the reason for that is we have not set up any categorical tags. So let's expand this and create a new categorical tag. So a new categorical tag. It's basically just a resource, except it has an icon and a display name. So I might call this building, and then for icon, let's just use the tower1 icon.png and pop that in there. And we're going to want to save this tag to the project. So I'm going to save as, and then let's find a folder for tags. We could probably just put it under objects and then create folder, and I'll just call this tags, and then we say tag underscore building.tres and hit save. Okay, so since we saved this resource to the project, we can pretty easily just add it into the placeable resource file as well. So we'll expand this, and we want to grab a new tag. So you can put any type of resource into here, but for it to work with this specific demo placement UI, it should be a categorical tag specifically. So let's look for tag building in the file system, drop that in there. Okay, now the tower is a building, so it should fall under the building category of our placement UI. So let's hit play, and we can see our building tag, and we can see our tower here that we want to place in. So if we click on tower 1, we can see a warning message. We haven't set a placement validator. And also, the building system suggests that we replace UI except as the build action with something else. So let's do both of those. On the building system, we want to expand settings, and let's go to placement validator, and we'll create a new placement validator. So this is just an embedded resource. Here you can see the base rules for your building system. So anything you want to be required by all objects you place into the scene by default, you would put into base rules. So this could be something as simple as just checking for collision under the square that you're trying to check on the isometric tile map. Okay, and for right now, that's all we really need there. To handle emitting all of the signals for the building system, there's another resource called a building signal bus. So through the signal bus, you can have any other script basically respond to what the building system is doing. And we're going to want to create that signal bus here as well. So click on the empty spot and do new signal bus. And you can see there's nothing really to it. We just need to save this into our project. And we could do that at the root. I'll create a folder for signals, and I'll just call this building signal bus. So if you want to be able to connect to the signals that are relevant to the building system, you do that through the building signal bus, and you can assign it in the inspector for another script, just like it is assigned right here. We'll come back to the RuleCheckIndicator template. That is going to be important if you need to check for collision, which we will want to, and most games would. But now let's go down to input actions for the building system, and let's change the build action to something else. So in project settings, let's add a new action. I'll call it build, enter, and let's make build left mouse click. So left mouse button, you just press it and then hit OK. And now we have the build action set. So in build action, I'll change that to build. We can also create one for flip horizontal. I will call it something like flip_h. So if we make that corresponding action in the input map, flip_h, add, and then let's say something like h on the keyboard to flip the object across the horizontal axis. Okay, so if we go ahead and hit play again, and then we go back to tower 1 and select it, you can see that our preview scene is generated. Now, this scene doesn't do anything, obviously, until we press the left mouse button to place it into the scene. If I left click to place it, we have an actual instance of it placed into the game, and all the scripts and collisions are re-enabled in that actual game scene. Now, you'll see a few issues here. First off, we need Y sorting on our packed scenes so that they sort with the other objects here. If you check the debugger, then we'll also see that we have some warning messages about there being no RuleCheckIndicator templates. So if there's no indicator template, then the building system can't check for collisions or check to make sure you're actually placing on the tile map. So it's pretty important to the build system in most cases. So in the file system, I'm going to search for Isometric to find the default RuleCheckIsometric.tscn template. So instead of using the original, what you might want to do is right-click and then do New Inherited Scene to inherit the base, and then you can change the settings on it. Or if you prefer, and this might actually be better, you could just duplicate it in, let's say, and then give it a new name, maybe Tower Defense. Hit duplicate, and then this will be completely separate from the one that's default to the package. So if I ever change this, it won't affect your custom RuleCheckIndicator. So let's move this out of the plugin, of course, since we don't want to mess with those files. And let's go to Objects, and I'll just move it into here. Okay, so we have our indicator template. We want to put that into here. So if we expand this, this is a packed scene. And then if we looked into the scene itself, so inside of here, you can see that we have a shapecast with some custom scripting and a sprite 2D for showing the indicator on top of the grid. Now, more than likely, the size and positioning of this sprite is not going to match your grid in the game by default. So you're going to want to change the settings here on this sprite to make it just match whatever is on your actual gameplay tilemap grid. And that also likely applies to the isometric shape that's added to the shapecast. So here we'd have a bunch of points. If we actually hide the sprite 2D, you'd be able to see this. So this is the shape right here. And if you move points, it's going to adjust the collision shape for the shapecast. So let's bring a copy of that into the gameplay scene. And we'll use that to kind of test how we should adjust it. So I'll just drag this onto the world 2D. And then let's take the tower and remove that. Apparently we have to do that on the world scene. So I'll get rid of that tower, save it, and now back on the gameplay scene, we can see our isometric RuleCheckIndicator. So really what we want this indicator to do is stretch in terms of collision shape, basically as close to the edge of our tile as we can get it, and then make the sprite reflect that change as well. So we can click here, and rather than actually editing the original indicator shape, we should just create a new one. So I'm going to click here and do, I believe we want new convex polygon shape. Okay, and then let's add 4 elements and take these points out to basically match where the grid tiles would be showing. So if we move this to the left, and then when we move this point down on the y-axis, which actually moves up on the screen, then we can just drag these out until it matches the size and shape of the grid. And we might want to hide the grid positioner temporarily as well. Okay, so you can see that with those 2 points set up, we basically get the shape there. Might want to round up to, let's say, -60 on the x, and then -35 on the y. And we can always adjust this later. So we're going to want to do the other points now. So just same values in reverse. Let's say 60 for this one, and then +35 on the 4th point y. So that gives us a collision polygon that I believe perfectly matches our edges. Now, to give it a little bit of leniency to make sure that we're not accidentally checking anything that's right on the edge here with the other borders, we might just want to give it a little bit of a margin zone. So I'm going to change it to -58.9, enter, and then 59.8 on the other x, and then we'll just remove 0.2 from the left and right, or the up and down as well. So basically I'm just taking all these values and subtracting 0.2 from them, and that should keep it from checking other tiles for things like collisions. Now I'm going to save this custom polygon shape into the project. So save as, let's put it in objects, and I'll just keep it there with the indicator. So I'll just call it indicator collision polygon. Save. Okay. And then let's jump into the packed scene, and I'm going to make sure that it's referencing that instead now. So let's quick load from our scene. We have the indicator collision polygon, not from the add-ons grid builder, but our custom one for our project. Okay, and now that's updated, and we just need to make this sprite kind of reflect that. So we can just pull on the edges here really to adjust our sprite, and then just pull this down here as well. And you can see that I'm just rotating, skewing, and scaling the sprite on the texture, which was really made for the square-based tile maps, which works here for right now, but you could also just create a custom texture that's meant specifically for isometric if you need to. Yeah, but let's make sure that the position, at least, is set to 0 on both X and Y. Okay, and now if we look at the gameplay, this is how our indicator will look. So one object might have multiple indicators for different squares, and each indicator is going to check for collisions and other problems and show visually if that specific tile has a placement problem. And if you try to place where one of the rule check indicators has a problem, then you should get a fail message. Now, to actually see those messages, you would want to use the build log or connect to the building signal bus in your own way. But that's the general feedback mechanism. Now, don't worry about setting the collision mask, because that's actually set up in the building rules, not on the indicator directly. So we can remove the indicator from our scene, and we just need to make sure that it's set up as the template on the building system, and that should be good to go. Okay, so for the collision indicators to actually show up and do anything, now we need in the tower, we need to create a collision polygon. So first off, let's make sure that our sprites are offset properly for the tower. So I'm going to right click here, add a child node. Let's do node 2D, and I'll say visual offset, and I'll call it visual offset. We'll bring the sprites and put this under here. And now if we click on visual offset, then we can do transform and just move it up. So I think we want -16 or so here. And wherever this little base transform for the root of this scene is, that's where it's going to be visually placed into the scene. So for the collision polygon 2D, it would probably be actually easier to see exactly where we need to place our collision points if we were placing it into the world scene. So I'm going to actually add the tower one back to the world scene just to position it in there. And then we can right click on tower, editable children, click on collision polygon, and then let's add it in the points. So you can either make it the full shape of the tower, or you can make it the tower itself. For a isometric grid-based game, this is probably going to be indistinguishable, because you would never really have two objects in one grid space. But before we get to that, let's jump into the tower and move the visual offset another 8 pixels up or so. So that should be like -24. And if we look at world, that's kind of more where we want it. We kind of want our tower positioned in the center of the tower, not so much off to the side. Okay, so now that we have that, we can click on the collision polygon, place our points. As long as it's basically within the grid space, we should be fine. So I'm going to left click here, kind of go up to there, down to here, down to there, and connect the final point. And that's our collision polygon. So I'm going to right click on these points, copy value. Let's go into the main tower scene, and I'll just paste that in here for the polygon array. Paste that in. Okay, and we have our collision polygon for this object. And we could probably actually just reuse this for all of our other towers, just copy and paste the polygon points. Okay, so now let's go back out to the world scene, and I'm going to remove the tower here. We don't need it. Save it. And then in tower 1, I just want to double check here on the tower base, the collision layers are set to 1 and 1. So now the final thing we need for the indicators to show up and check collision is the collision rule to actually be added. So in building signal bus, so in placement validator, expand here, and we'll add in a base rule. So we can select from the default rules inside of Grid Builder, and we want a collision check rule. So collision check rule, we do not want it to pass on collision. We want it to fail on collision, so we leave this unchecked. Okay, so for our rule check indicators, we want them to scan on layer 1 to see if there are any objects under the rule check indicator, which the indicator would collide with. So we're going to leave collision mask on 1, and that means any objects that are in that tile that have a 1 collision layer are going to make this rule fail. And then we want to apply this to any objects that we're placing into the scene that happen to be on layer 1. So when we're placing objects into the scene, we apply this rule to an object that's on layer 1, and then we check against layer 1 to see if there's other objects that it would collide with. Okay, and then now we can hit play, and let's get the tower. you can see our rule check indicator there is under the tower, exactly where we expect it to be. Only one was generated, which means that our collision shape is small enough that it fits onto the grid space properly. If we had a giant collision shape, more rule check indicators would be generated. So if we left click to place, you can see our object gets placed into the scene, but as soon as we do, the next object we're going to be placing onto that spot, the rule check indicator turns red because there's a collision now. So our rule is failing, the collisions check rule is failing because there's an object blocking it on layer 1. So we can now only place one tower on each space, essentially. If I left click, you can see, well, it's not placing towers. We can't tell for sure because we don't have a build log added. Okay, so if you want a build log to show feedback messages from what's actually going on internally in the building system, and you probably want to at least start with the default build log, then let's actually add one in. So I'm going to search for build_log, and we can grab the build log tscn and put that in our canvas layer UI on the gameplay scene. We can see it's going to show there on the bottom left by default. We want to connect this to the building signal bus. So for the building signal bus, let's search signal and bring in the resource into here. Now, if you want, you can add a background to this build log so that it's a little bit easier to read the text. So we could just right click and editable children, jump to the 9-patch rect, I guess, and add in, let's say, a gradient texture 1D inside of here. Just make both sides black. And then lower the alpha transparency. So there's a few places you could do that. You could do that on the colors here individually, or we could just go to visibility, self-modulate, and lower that way down to something like 40. So now if we hit play, we'll have our build log in the bottom left. It's visible, but we can tell where the build log is. So now if we place our objects, we should get some indication of what's going on there. Now, by default, it's not going to show very much. If I fail a build, we can see the reason why it failed. Must have no collisions. But there's more stuff we can turn on in the build log if we want. So when we're building the game, we probably do want more messages. So we could do show validation message. You can print on a drag build. I probably wouldn't recommend that because that will give you a ton of messages. But print success reasons might make sense. So now let's go into here and let's place. So we place the first one. We can see all the validation checks were passed. And here's the message from each one. No placement collisions found. So therefore we built the tower. And if we fail, then we'll get red messages. Rules failed, must have no collisions. And that's basically how we know there. So I did mention drag build. It might make sense for a tower defense game. So let's go to build system. And to enable that, there's just drag multi-build. If we click here and hit play, now you can build multiple at once just by left clicking, holding, and dragging around the screen like this. We can see a slight problem though, which is that we can actually place our objects completely off the tile map grid. Now we can't if there's a collision, but we want to add another rule to the system. So to check that we're placing onto a tile that actually has data, let's go to the placement validator on the building system, add an element, click the drop down, and we want to WithinTileMapBoundsRule. So if we click here, we jump in here. So we're going to apply this to any object that is on layer 1. And basically we're just checking that there's tile data under wherever we're placing it on all of the rule check indicators. So if we hit play now, then we can select our tower. If we go out here, it's going to say tried placing outside of valid map area. So we can't do that. Now we can still place within the tile map grid as long as there's no collision. But we have 2 potential fail points here. Now, something you might notice is that the indicator looks the same for whichever rule it's failing on. You can actually customize that by adding fail visual settings here for the rule that you want to change, let's say, the color of the texture on. So if we click here and do new indicator visual settings, then you can add a custom texture if you want, or you can just modulate the color of the texture to be, let's say, orange. You're going to want to give it a higher visual priority than 0 so that it overrides any other failing points. Or if you want these settings to override above other rules, other failure points, then you can increase the visual priority. So if you want within tile map bounds to be the first rule that gets basically shown visually, because it can only show one at once, then we would just increase this. And you can also do the same thing with CollisionSCheckRule. If you want a custom visual settings here, then you can just do this and make it kind of like a reddish purple. Let's make it a little bit different so we can tell the difference. So now that there's custom visual settings, if this rule fails, it's going to show purple. If this one fails, it's going to show orange. But if both of these fail, it's going to show the one with the higher visual priority, which is down here. So currently we do actually need to assign the texture here for these to trigger. In the future, I might just make that completely optional though. So let's grab .png. We can do, let's say, the grayscale tile overlay. So if you use white and black, then that's going to multiply by this color more properly. So I'll put this in here and down there as well. We hit play. And now if we try to place it into the scene, okay, so here's our green default valid placement. And then we can see the collision shape placement is now kind of like pinkish red, hot pink, I guess. And if we go off the grid, then we have our yellow texture showing. So that's just another way you can kind of customize the visuals there. Okay, and lastly, we want to fix this Y sorting thing. So in local for towers, I'm going to take this node and let's turn on Y sorting. So if we do that in the local inspector while the game runs, it should actually update automatically in the game as well. So if we turn that off, you can see it's not sorting. And if we Alt-Tab and turn it on, you can see it's sorting again. So that's just one of the things you can actually do during gameplay. You can mess with the properties. It's pretty handy for debug testing. And yeah, I would probably go through your level scene and just make sure everything, like the world, the level, and the towers are all set to Y sorting. Just seems appropriate. So in the world scene, I'll take world, let's make it Y sorting. Level will be Y sorting enabled, and yeah, so on and so forth. Alt-Tab back to the game, just make sure it didn't mess up anything. And we can now place our towers on our tile map grid. But not off of the tile. But not in the spaces where we don't have tile data. So we're limited inside of these tile spaces inside of here. So let's show one more case where you want to make specific tiles unbuildable so that you can't just place onto any tilemap tile. Regardless of whether there's an object there already or not. So we're going to want to grab another tower defense tile. So let's search tower defense. So I'm going to look here for, let's say, sloped grass or something of that nature. So looking inside of here, I can see a bunch of tiles that might make sense for being unbuildable. But I think appropriate to a tower defense game would be the road where the enemies walk on. Generally, you wouldn't want to be able to block the enemies and prevent them from getting to the goal. At least as a developer, as the player, that would be really handy. So let's say that these road tiles are unbuildable by the build system. So first we're going to need to add one of these tiles in. So let's see, this is tile 89. So if we just search 89, we can put that image into here. So on tile set, setup mode, and we do need to be on the world scene for this, so that we edit this tile map directly in its original source. We just drag. Then let's use selection mode on tile set, and I think we can just drag tower defense 89 into here now. So let's automatically create the tile. Obviously, this needs some adjustments, just like it did before. So if you get serious about your workflow, there's probably some way you can automate kind of like setting up these tiles so that the offset is correct and the sizing of the region is correct every time. So I think we just need to do 124 and then 123 here for the tile. 123. Yeah, okay. And then we need to go to selection on the tile. Yeah, I guess for this tile, we actually don't need to offset the origin. Okay, so how do we make this tile unbuildable, but the original tile buildable? Well, we would just create a custom data layer on our tile map. So in tile set, you can see down here, custom data layers. We add an element, and I'm going to call this buildable. And if you click on drop down for type, we do Boolean. Save that. And now with this custom data type, we can tell any tile whether we want it to be a buildable tile or an unbuildable tile. So I'm going to select on this tile, and then we're going to go to custom data and turn on custom data 0. So keep this actually off so it's not buildable. then click on the original tile, click here, toggle it on to be a buildable tile. Okay, so now this one's unbuildable, and this one is buildable. Now how do we check that with a rule so that it actually works with the build system? So if we go to gameplay, click on the build system, we can go down in here and add an element for a rule. If you click here, we can do ValidPlacementTileRule. So with that, we just need to check expected tile custom data. So I'm going to add to this dictionary, basically the same key value pair that you saw on the custom data of the tile set. We need to add those values in here. So new key is going to be a string name, and we want that to be buildable. And then new value is going to be a Boolean, which we want this to be on. Add key value pair, and then that's the data we're checking for. We're checking the buildable tile data, and we're making sure that it's on in order to place onto the tilemap grid. Now, if I recall, because in order for there to be tile data, there has to be a tile under it to begin with. This actually makes our WithinTileMapBoundsRule unnecessary. So we can just copy the visual settings over from here to here, if we want to keep using those same colors, and then just get rid of the WithinTileMapBoundsRule. And we'll just use this one to replace it. So this is just WithinTileMapBoundsRule with the extra step of also checking the custom data, essentially. And once again, I do want to emphasize that if you have any other creative ideas for your own building rules in your game, feel free to add them, and then you can just add them either to the placeables or the placement validator directly, and use that as checks against what's going on in your game state. Okay, so with that, we should also place some unbuildable tiles so that we can test that. So let's go to the game world. And let's just place some tiles onto Tilemaps. So we want the pencil tool. We're going to select this tile, and let's draw our road there. Okay, so now that we have that, let's hit play, and let's see if we can build onto the road. So we can see that obviously we have no tile data in these outer areas still. So that's being handled by the same rule that is going to actually prevent us from building onto this space down here. So tiles in expected tile area are missing. That message doesn't really help too much. So what I might do is go to the building system on this and just set a custom failed message. So I'll say placement must be over buildable tiles as the failed message. Okay, now if we go back here and we left click, we can see that immediately updates. Rules failed, placement must be over buildable tiles. So if you do want to customize the messages, you should be able to do that within the rules for the most part. And if we place out here, it's still good enough. Placement must be over buildable tiles. Well, obviously, there's no tiles there, so it makes sense that we're failing that rule as well. But we can place onto the tower areas, like so, but we can't place over an existing tower, like that. So basically, we have the gist of our working system now. So you know, we give our towers some projectiles, we spawn some enemies, and then you have a really typical basic tower defense game. So I think I have a little more time, so I guess we'll go through if you want to have like a player inventory. We can create a gold resource real quick that you would use for spending on your towers. So I'm going to grab Grid Builder Inventory 3.2, and let's bring that into our project. And let's enable that plugin. And inside of here, we just have a few classes. This is really meant to be more of a testing inventory, not to be a full replacement of a system. It doesn't have a UI. But you can use this with the spend materials rule that's included here if you just want to test spending some kind of gold material on building your objects. So let's add the inventory to the player. I'm going to right click on the player, and we're going to add in an item container. So our item container can hold items of the allowed tags. Not so relevant here, but we want to fill the slots with some kind of resource. So let's create a new base item stack. And this will be a new resource type that we'll create. I'm just going to do new base item here. And we'll save this and reference this in the spend materials rule as well. I'm just going to call this gold really quickly. And like you'd probably give it an icon. I can see if there's any textures we can use. So once again, we have the tag thing going on, a stack maximum. So let's just say 1,000 is how much you can have in a stack. And a player has 1,000 gold to start, nested down here. I'm going to right click on the base item and save that into the project. So let's go up a level. I'll create a folder for resources. And let's say resource gold, save. Okay, so now it's a stack of resource gold. We have 1,000, and we can spend that inside of our item container through our build system. So the build system, as I mentioned at the start, requires a placer. So if you have these build rules checked, building rules checked, it's going to check the player for a item container to see if it has enough resources to spend and actually build the building. Now, of course, that's just my implementation of how to spend resources, but feel free to create your own custom rules as well. But once again, different towers are going to cost different amounts of money. So this is a really good example for when you would want to add a rule to the placeable and not the placement validator directly. So if we search for placeable inside of the project, let's get the placeable tower 1. Placement rules, let's add in 1. We're going to want our spend materials rule, not the generic one from the base build system, but one that basically requires the classes that are in the grid builder inventory directly. So we're going to have a base item stack here, and this base item stack is going to basically represent how many of a certain resource we need to spend from the item container inventory. So let's quick load our gold resource, and then let's say 200. So materials to spend, we're looking for 200 resources inside of the item container, and we get access to the item container from the placer dependency. It looks for player, finds the item container, and then if the item container has enough resources to spend, then we can place the object, and those resources will be subtracted from the item container. And if we're out of resources, we can't build. So let's test that. I think that's all the basic setup here. So we should be able to place 5. 1, 2, 3, 4, 5, and then we do another one, 6. Failed because we don't have enough gold materials. Now, obviously, you would probably have a little UI as I set up in some of the other grid builder demos in the dev project for showing how many of each resource you have in your resource container. But that's the general idea here. And of course, as you add more rules, if you're going to have a lot of rules, you may eventually want to turn off showing that, each of the rules passed, because that's a bit unnecessary for how much information the player really needs. So, when you're out of debug mode, then you can just go to the canvas layer, game log, and turn off success reasons. I would do that. I think I would keep validation message and failed reasons on. Hit play. And now it'll be a little bit cleaner. So all checks passed, built tower. That can work there. Feel free to customize the build log too and have it say whatever you want it to say, really. But these are just the messages that are coming back from the build system, and you can filter those out however you want. So that in a nutshell is how you use the grid builder system with a isometric tile map, being able to place onto the grid, checking different rules such as placing onto valid tiles, placing onto buildable tiles, and having enough resources to actually build your towers or whatever is relevant to your game. And don't forget, because all you're doing is placing a packed scene into the game, it does not need to be an actual building. It can be any object or character you want to be able to place into the game, so that's really up to you on how you use it. That's going to pretty much wrap it up for this tutorial. So I've been Chris. Thanks for watching to the end. You can find Grid Builder on itch.io, my Ko-Fi page, and Patreon as well. Feel free to shoot me any questions or suggestions if you have any, and until my next video, I'll see you then.